This is a GATE 2020 problem given in ECE paper for 2 marks. Okay, here before going to the problem, I want to discuss setup time and hold time in general. See, suppose I take a flip-flop. There is a D flip-flop and a clock input is here. I assume the delay of this D flip-flop is suppose 3 nanoseconds. And after the D flip-flop, there is some combinational logic. See, there is some combinational logic. It can be one gate or cascaded gates. And through this, the signal is connected back to D flip-flop input. Suppose this combinational logic is having a delay 2 nanoseconds. And D flip-flop setup time some 3 nanoseconds. And hold time 1 nanosecond, I am assuming. Okay, here when I apply a clock, suppose a clock is applied at 0 nanoseconds. Here it is a positive trigger, that means a positive edge is applied at 0 nanosecond. So if I apply a clock at 0 nanosecond, the delay of D flip-flop is 3 nanoseconds. That means this Q will change after 3 nanoseconds. Now this combinational logic is having delay 2 nanoseconds. That means this input D will change at 5 nanoseconds. Okay, so the total circuit is taking 5 nanoseconds to produce the change in the output. Okay, see here, setup time of this flip-flop is given 3 nanosecond. That means at 5 nanosecond my signal is changing. After that I should not change that signal at least for 3 nanoseconds. That means up to 8 nanoseconds I should not apply the next clock. That means if I apply my clock at 0, I must wait for 8 nanoseconds because 5 nanoseconds for getting changed input at the D and 3 nanoseconds is the setup time. So the minimum clock period I must take is 8 nanoseconds. Okay, that means first edge came at 0 nanosecond, the second edge I can apply at 8 nanosecond. But here comes the hold time. See, after 8 nanosecond, your input must not change further for hold time. Here, what is the hold time? 1 nanosecond is the hold time. That means between 8 to 9, your input should not change. But actually, if you think, if I apply edge at 8 nanosecond, this 3 nanosecond flip-flop delay and 2 nanosecond combinational delay, that means up to 5 nanosecond there will be no change. That means up to 13 there is no possibility of the change in the input. So I can ignore the hold time. I can ignore the hold time as long as my hold time is less than this delay. What is this delay here? 5 nanoseconds. So here my hold time is only 1 nanosecond. I can ignore the hold time. Only the hold time is taken into consideration if the hold time is greater than this delay. Your flip-flop delay and your combination delay together 5 nanosecond. If your TH is greater than 5 nanosecond, then only you take that into consideration. Okay, so as your hold time is less than that 5, those I can simply proceed with 8 nanosecond is the minimum clock period I should maintain. So my maximum frequency is 1 by 8 nanosecond. So in this way we calculate. Okay. So here the simple, if I say the first flip-flop delay and combinational delay total 5 nanoseconds. Later I should add that setup time. Setup time is 3, that is up to 8 nanoseconds. I should not apply the next clock. So the minimum clock period I should maintain is the 8 nanosecond. Okay, so you can ignore the hold time as long as it is less than this. Okay, so coming to this problem, here there are two flip-flops. So here there are two flip-flops and there is some combination logic. Okay. So first you need to calculate after applying a clock, after how much time the input for first flip-flop is changing, after how much time input for second flip-flop is changing. And here if you look at this problem, setup time, hold time are different for the both flip-flops. Okay. So first you need to calculate the first thing. The first thing you need to do, okay, I erase all these things. The first thing, two flip-flops you calculate after how much time each flip-flop input is getting changed. Okay, so if I apply my clock at 0 nanosecond, just to look at this circuit. So just here if I apply my clock, at 0 nanosecond, both flip-flops are connected to same clock, simultaneously they triggered. First flip-flop produce output at 3 nanosecond, second flip-flop produce output at 8 nanosecond. Now this second flip-flop output straight away connected to the first flip-flop input. That means my first flip-flop input will change at 8 nanosecond. Now similarly calculate second flip-flop. See, this first flip-flop output given to this combinational logic here, it is taking 2 nanosecond, here it is taking 2. So 3 plus 4 total. After 7 nanoseconds, this flip-flop is getting changed its input. And I know after my input is available for the flip-flop, I should not change this according to the setup time. Here what is the setup time of this flip-flop? 5 nanosecond. So the input is getting changed at 8 nanosecond and my setup time is 5 nanosecond. That means here I am getting clock period according to this 30 nanosecond. And coming to this second flip-flop, the second flip-flop input is getting changed at 7 nanosecond and its setup time is 4 nanosecond. That is total 11 nanosecond. Okay. So the first flip-flop, the clock period should be 13, second flip-flop clock period should be 11. So which one you choose? Absolutely always you get the bigger one, because this, if I take my clock 13 nanosecond, that satisfy the both flip-flops setup violations. So the minimum period here 30 nanosecond. But you know one more thing here, hold time. The hold time is only problem if it is greater than this. Here my input is changing after 8 nanosecond for this flip-flop. If my hold time is greater than 8, then only there will be a issue. But here it is only 1 nanosecond, I can ignore that. Similarly, the second flip-flop, I am getting the input change at 7 nanosecond. My hold time is 3 nanosecond. So still the hold time is less than the 7 nanosecond. I can ignore this also. So here hold times does not create any issue. So here the minimum pulse duration you should maintain is 30 nanosecond. Minimum pulse duration. That means minimum clock period. That means every clock you should apply with minimum space 30 nanosecond. And he is asking what is the maximum clock frequency. If the minimum period is 30 nanosecond, your maximum frequency is 1 by 13 nanoseconds. Okay, yeah, that will get you 76.9 megahertz. Okay, here 76.9 megahertz, and in the key it can be given 76 to 77. You enter any value, it will be treated as a correct answer. Okay, right. Now you may ask, sir, suppose if this old time here it is only 1 nanosecond, it is less than this 8 nanosecond, so there is no issue. Suppose if this old time is given 9 nanoseconds, usually the setup times are generally longer. Okay, anyway, if I give this hold time is 7 nanosecond, which is violating the case, because this flip-flop input is changing at 8 nanosecond, but the hold time is 9 nanosecond. Then in that case, this 30 nanosecond was your minimum period, that you must change it to 14 nanoseconds. you must make it to 14 nanoseconds so that there will be no violation. That means only the difference you should add. Suppose here if I give 11 nanosecond hold time, 11 nanosecond hold time means it is greater than the input change by 3. Okay, so it is by 3 means your original answer was 13 plus 3, it is 16 nanosecond minimum period you should maintain. In that way calculate. Okay.